In example 3, you're challenged to imagine that Matteo is skydiving. You're told that Matteo has leapt from a plane and that 10 seconds later he has still not opened his parachute and is falling at a constant 56 meters per second. The fact that his velocity is constant is important in this problem, and we will come back to it in a moment. Using vectors, you draw the forces acting upon Matteo. You're told that Matteo has a weight of 980 newtons. Weight, of course, is the force of gravity, which always acts downward, so you show a vector indicating Matteo is falling down, or has a force pulling him downward, labeling it the force of gravity of 980 newtons. You're then asked several questions. First one being, are the forces acting upon Matteo balanced or unbalanced? Recall in the problem that you were told he is falling at a constant 56 meters per second. A constant velocity means that the forces must be balanced because motion is not changing, it's constant. For this reason, the forces are balanced. The net force can then be determined. The net force on Matteo must be zero. Balanced forces are the same thing as a net force of zero. If he has a downward force of gravity of 980 newtons, this means that the upward force of wind resistance must be an opposite 980 newtons so that the two of them can balance one another. The net force in this case is the force of friction minus the force of gravity. The positive y direction is the upward direction, so friction is a positive number. The downward y direction will be gravity, so it is shown as a negative in the calculation. 980 newtons minus 980 newtons is a net force of zero. What does this mean for Matteo? Matteo will continue to fall at a constant speed of 56 meters per second until he opens his parachute, which changes the force of friction. That's not part of the problem. The first law says that motion does not change unless an unbalanced force is acting upon an object.